do to make this look nicer. It doesn't look that bad. So first of all, we have to realize, what does that mean? What does 2/5 power mean? Can someone tell me what that means? We talked about this. What does it mean? It means what, Dev? Yeah? What? Nope. Nope. It's the fifth root, 243 to the second power, right? And you could do the square and then the fifth root. Why wouldn't you want to square it first? Yeah, don't make things bigger. Make it smaller than bigger. Don't make it bigger than smaller, right? So you're looking for the fifth root of negative 243. That is a root that you might know. That is a root you might know. What is it?
I just have a question.
Yeah, go ahead.
Can we write it as 2 the square root of negative 243 to the fifth? Or is that completely wrong?
Could you do what?
Like, you just switch the 5 and the 2.
No, you cannot do the square root. This is not square rooting. That's to the second power. The reason is it's negative 243 to the 1/5 to the second power. So you could switch the positions, but if you switch the positions, you could write it as the other way you could write it. So you could, this thing right here is also equal to negative 243 squared, kids, to the 1/5 power. But we just said that's not a very good thing to do, because do you want to square 243? No, so don't do it that way. So here's the thing. You might recognize this right here. You might recognize what the fifth root of negative 243 is. What is it? It is close. No? I'll give you a hint. Whee!
Oh.
It's negative 3. That right there is negative 3. That is negative 3, so it's negative 3 squared, which is what? 9. Now the other way to think about this, besides memorizing it, here's the thing. If you don't have a nice root of 243, you can't do anything to this, right? There's nothing else you can do. So you assume that there is, and then you can start testing numbers. It's not going to be 2 to a fifth power, because 2 to a fifth power has to be what type of number? It has to be even. Is 243 even? No, 4 to the fifth is huge. So you could do it out. It just helps to remember 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81, and 3 to the fifth is 243. This is the edge of what I would expect you to know. The edge. I don't really expect you to know 3 to the sixth, for example. 3 to the fifth would be as high as the third power. 3 to a power would go. Root in this case. It's the sixth root. What power is it? So should you... Well, the negative... What does the negative do? It's just 1 over this thing, right? Another thing you can do... I showed you this before. Another thing you can do is if you see a negative power, you can just flip over what's on the inside. If you flip over what's inside, what does the power become? It can be positive, yeah. You can just do that. It just flips it over.
Oh.
That's another thing you can do. Because look, think about, I'll prove it to you. A over b to the negative 1. What does that equal to? 1 over what? Let's make it to the negative n. A over b to the what? N power, right? But what does that equal? That equals 1 over a to the n over b to the n, which is what? 1 times what? B to the n over. But what is that? That's b over a to the n. So what did we just show? A over b to the negative n is equal to b over a to the n. So if you flip it, it just becomes positive. So that's something you could do. But it's sixth root and fifth power. Do you want to do the fifth power first? Yeah. Gosh, no. 64 to the fifth power is big enough. 729 to the fifth power, no. So if this is something you can work with, you have to assume that there's a nice sixth root to these things. And this already kind of violated what I just said. I wouldn't ask you, but what's the sixth root? So this is, what is this? This is 64 over 729 to the 1/6 power to the fifth. What's the sixth root of 64? It's 2. And do you want to guess what the sixth root of 729 is? 3 to the fifth is 243, right? So 3 to the sixth is 243 times what? 3, right? 243 times 3, what is that? 9, 1, 2, 6. Oh, it's 729. So what's the sixth root of 729? 3. And this is raised to the what power? 5. So what 2 to the fifth is? You could leave it like that. I would give you full credit right there, but you could write it as 2 to the fifth is what? Not 10. Careful. Careful. Not multiplication. Not that kind of multiplication. 2 to the fifth is? Ready? 2, 4, 8, 16, 32. And 3 to the fifth is 243. Now, generally speaking, what do you think is easier to work with? Something like this or something like this? Yeah, I would say A is a little bit nicer, generally speaking, but this right here would be fine. Either one would be fine. If I don't specifically say eliminate all powers, leave it like that, because don't waste your time and add the added risk of trying to find out what, yeah, it's bigger, it's more annoying, I know. Trick I just showed you, what can you make that equal to? Yeah, so it's going to be 27 over 125 to the what? What root are we taking? What root? Third root. What's the third root of 27? 3. And what's the third root of 125? 5. And what power are we raising it to? Second. So this could be 9 over 25. Done. So what did I tell you you could do? What's the reciprocal of 81? 1 over 81 to the what power? 3 over 2. What's the square root of 81? So it's 1 over 9 to the what power? 3. And you could leave it like that. Maybe you know what 9 to the third is. 9 times 9 is 81. It's 81 times 9, so it's actually it's bigger, right? Another way here, can I just show you another way to attack these big exponents? You might not recognize 9 to the third, but what is 9? There's a way to rewrite 9. It's 3 what? It's 3 squared, correct? So this is the same thing as 1 over 3 squared to the what? Third. So that's 1 over 3 to the what power? No. 6. You have to multiply, right? And we just did 3 to the 6. What is 3 to the 6th? So what I'm saying is, if you ever have to raise powers, memorize the 2 to the powers, 3 to the powers, and that's about it. Nothing else. Okay, put everything away. Exponent rules that you now know. And the thing is that all of the exponent rules that you have worked with, the same thing applies to rational exponents. The same thing applies. So for example, if I had, z to the 1/12 over z to the 1/3, how do you simplify that? What do you do with the exponents? You subtract them. So that would be z to the 1/12 minus 1/3. So you need a common denominator. So that'd be z. How many thirds or how many 12s? There's 4. Sorry, 1/12. That's going to be 1/12 minus what? 4/12. So that's going to be equal to, I can almost write it as z apparently. Z to the negative 3/12, which is z to the what? Negative 1 what? Negative 1 over 4, right? So this right here, that's called what? This is called exponential form. The other form we're dealing with is radical form. So what does that negative power do? Yes, it flips it, but it puts it in the denominator, right? So you know that z to the negative 1/4 is equal to 1 over z to the 1/4. What does 1/4 power mean? Don't say the fourth root. It means the fourth root. To the 1 over n is to the nth root, right? So this is 1 over the fourth root of z. These are all different ways to write the same thing. They're all different ways to write the same thing. So what you're generally going to attack the first one right here. What should I do on the first one? How do I simplify it? What do I do?
You should write it as the square root of x to the 5th over x to the 8th.
I like that. And then what can you do?
And then I subtracted x to the 8th.
You subtracted, yeah, so you get x to the what power?
X to the negative 3.
Got it. And then?
Moved it to the bottom. So I did 1 over x to the 3rd.
1 over x to the 3rd like this?
Yeah.
Well, that's a mix of radical and exponent. So if we want to get rid of that radical, what does square root mean?
2 to the 2nd.
No, it does not mean to the second. What power is square root?
2.
No, that's squaring. 1/2. Do you understand that 1/2 is not equal to 2?
Oh, yeah.
Okay. So this is 1 over x to the 3rd to the what power?
1/2.
Okay. So then what do you do with that power? So it's 1 over x to the what? 2. That would be fine. And if I said you could write negative exponents, you could write it as x to the what power? Negative 3 over 2. You could write it like that. What about this one right here? How do you attack this one? What do you do? What power is cube root? So this is m to the what power? What power is fourth root?
1 over 4.
So it's m to the 1/3 to the what power? And what do you do with powers of power? You multiply, so it's going to be m to the, done. There it is right there. 9 over 4, correct? And it's going to be x to the 15 over 8. Yep. What's the bottom going to be? W to the what? Negative 9 over 4. And x to the what? So all I've done so far is multiply -3 by all the powers. I've taken this -3 and I multiplied it by all the powers. Are you with me so far? Have we done things like that before? Absolutely. Are we done though? No, we're not done. We're not done at all. Because what do you... Great.
Do you need my charger?
I'm good so far. Why isn't this done?
Yeah, the negative.
Because you can simplify. Yeah, so like this right here and this right here can be simplified, right? Let's call that part A and part B. Which one do you want to do first? Sure, so that's going to be 2 to the 6th, and it's going to be w to the 9/4 minus what? -9/4. That's correct. You subtract the powers. And then the next one's going to be x to the 15/8 minus what? What are you subtracting from 15/8? 3/2. So it's 2 subtractions right there. So it's going to be 2 to the 6th w. What's 9/4 minus -9/4? 18/4, correct. And this is going to be x to the... Oh, what do we need? To add or subtract fractions, what do we need? Common denominator. And yeah, so we need to find an LCD. So it's 15/8 minus what? 12/8, right? Because you have to multiply by what? 4? So it's going to be what? 3/8. Now there's only one last thing you can do to this. What's the one thing you could do to simplify it? And it's not the 2 to the 6th. It's okay to write it as 2 to the 6th. There's one thing there that can... Yeah, what's that fraction simplify to? 9/2 x to the what? 3/8. So are you with me so far on that?
Yeah.
Okay, so here's the thing. Is that radical or exponential form right there? Exponential. It is exponential form. If I asked you to, could you write that in radical form for me? Try it for me. Write it in radical form. It's not going to look too pretty. Use parentheses carefully, okay? 2, 4, 8, 16, 32, 64. Thank you. And what's the next thing going to be? What does that w to the 9/2 turn it to? Yeah. Or, yeah, it could be the square root of w to the 9th. Or what could you write it as? What could you write it as? The 9th root of w. Oh, excuse me. The square root of w to the 9th. You could write it like that. Or if you wanted to, you could write it as the square root of what? W to the... You could write it like that. That's fine. It is totally fine if you put the little 2 in. Do you see how I put the parentheses around it, though? Why is that kind of important? If I don't put the parentheses in, you might read it as 64 squared. Really common thing. Even if you write it nicely, it might even really look like it's supposed to be squared. So what's the next one going to be? What root? 8th root of... And remember how I told you generally don't want to do the cube first? Or like the making a bigger thing first? It depends on how you want this to look. This is the same thing as 64 times the square root of w all raised to the what power? That's the same thing. You're allowed to do that if you want to. These are the same. It's the same. Either way is fine.